Alright, this is the last video for the day as well as for the week. We looked at an example where a word problem was converted into solving a right triangle. Now there are some common terms that are used in these word problems. Let's look at what they mean. If you are on the ground and you are looking up to a high object, then that object is say vertical, then from your line of sight, which is about here, this angle that is measured of that object is called the angle of elevation. Similarly, if you are at a height looking at something downwards and you draw a straight line from the horizon, which is your level of your eyes, then this angle that it makes with the object on the bottom, that's called the angle of depression. So these terms, angle of elevation, angle of depression, whenever you see them, should immediately pop in, like it should, the scenario should be, if it's elevation, you are on the ground looking at something high up. If it's depression, you are at a height looking at something down below. Okay, so let's look at a couple of examples. Again, the process: read once, second time, identify the elements, label everything, write what's given to find, draw the right triangle again, and then solve. A transit is positioned at a horizontal distance of 35.00 meter from the foot of the tower. An angle of elevation of 58.00 degrees is read inciting the top of the tower. The height from the ground to the transit telescope is 1.7 meters. Determine the height of the tower. Okay, let's go back and identify the elements. A transit is positioned at a horizontal distance of 35 meters from the foot of the tower. So there's a transit and a tower. An angle of elevation 58 degrees is read inciting the top of the tower. The height from the ground, so there's a ground, to the transit is 1.7 meters. Determine the height of the tower. So here you are. This is the transit and this is the tower. And this height of the transit is 1.7, and I've labeled two unknowns, an x here because that's a right triangle, and the h which we are trying to find. So let's see what's given. Let's say I call this length a. Then we're given a is 1.7 meters and you have a 58.00 angle of elevation. To find is the height h. Solution. The simplest solution is that h is x plus 1.70 meters. Right? From the diagram, h is this length plus this bottom length, which corresponds to a, which is 1.7. So now my new goal is to find x. I have a right triangle, so I go ahead. X 58.00. Oh, and I missed a piece of information. Let's say I call this length y. Then I'm also given that y is 35 meters. So this is 35.00. Alright, so that's opposite, that's adjacent. Opposite adjacent means I'm working with tan. So tan of 58.00 is opposite over adjacent, which is x over 35. Cross multiply to get x is 35 tan of 58 degrees, which is 35 tan 58, 56.01. Not done yet, because h is x plus 1.7, so it's 56.01 plus 1.7, giving me 57.71 meters. In the end, always verify that what you had here for to find matches up with what you actually found in the solution part. Now this is an open-ended problem here, in the sense that there are no numbers given. But it's sort of asking you to use your knowledge to solve this problem. What does it say? A surveyor wishes to measure the distance between two horizontal points. The 2 points A and B are separated by a river and cannot be directly measured. Describe a method to do this using trigonometry. Note, you have a device to measure length and a device that can measure angles. So there's no, let's read it for the second time. So you have a surveyor. There are two horizontal points, A, B. There is a river, and that's all you know. So let's draw a river. Let's say that's the river. 2 points. Horizontal meaning you're not at an elevation, so it's not 3-dimension. We can draw it in 2-dimension. The 2 points are, say, A and B. So it doesn't say that B has to be directly opposite, so B is anywhere here. Okay, now what do I have? I can measure length, I can measure angle, but I cannot measure length across the river. Maybe because the river is too wide, there's no way to go across it. So one possible way to do this, knowing that I can measure length and angle, is I know I can work with right triangles. We just learned that. So I want to create a right triangle somehow. So here's what I'm going to do. I'm going to start at A and I'm going to start walking to the right. I walk to the right and I have a device with which I can measure angle. And I walk until I reach this point C, from where when I look at B, the angle is 90 degrees. I put a stake on the ground there. I go back to A. From A, I have this device and I measure this angle, theta. Now remember, what is given? Theta is given. Why? Because I measured it. The distance AC can be measured. Why? Because I have a device to measure length and A and C are on this side of the river. To find is the distance AB. So solution, again I have reduced this to a right triangle problem, ACB theta. So I'm working with AC and AB. AC is adjacent, AB is hypotenuse. Adjacent hypotenuse implies cosine. So I set it up. Cosine theta equals SOHCA, so AH, AC over AB, which means my angle is cosine inverse of AC over AB. And that's how you can measure the, we're not finding theta. We know theta, we know AC, we are finding AB. So AC equals AB times cosine theta, or divide by cosine theta. So AB equals AC over cosine theta, or AC secant theta. So what we've done here is we found a general method, no numbers involved. Now you can tell anybody who wishes to calculate the distance between two horizontal points, you can tell them, take these two devices, walk from A to C, measure AC, measure theta, plug into here. AC divided by cosine theta, that's going to give you the distance between 2 points. So this is an example of how we can use trigonometry to solve surveying problems, as well as a whole range of real life problems. You can make measurements, or you can find values for lengths and angles without actually making measurements. That's it for this week.